Hello friends, welcome back. In previous session we have seen transformations, action and set of operations, and we have covered a couple of important concepts on RDD. Today we are going to cover caching and persistence, why we need caching in Spark Job. I'll give you one scenario as I mentioned in the previous session that RDDs are computed when some action is performed, right? They are not computed on any transformation method. They are computed whenever we call our first action. So suppose we have a couple of you have RDD and you have done couple of transformation on that RDD, but you have not called any action. When you call the action, then only computation is happening. So I'll give one scenario. Suppose you have RDD and you are calling back to back couple of actions on the same RDD. What would happen? The RDD will be computed each and every time the action is called. This is not good. This is a very expensive operation. Let me explain the code. Uh, Let me open the one of this method. Okay, look at this example. I have employee. I'm then calling a filter method. Then I'm calling a count. Count is one of the action. Correct. Suppose I again call collect method on this US employees, which is another type of action. Then suppose I'm calling save as text file on the same US employee. It is one of form of action. Suppose I call the reduce method. It is one of the form of action on the same RDD. So what is going to happen? So US employees will always be computed on each action. So to avoid that, what we can do? So I have written one small program to showcase you. I have an RDD created from a list of integers, and what I'm doing, I'm persisting it using one of the storage level. So what are those storage levels? I'll explain later. So suppose I have an RDD, then I'm doing reduce and count. So what would happen? Since I use persistent method, this RDD will be stored in the memory. So when I call reduce account method, this RDD will not be computed. It will pick from memory itself. So it will improve performance of your application. So what I'll do, I'll cover a couple of storage level which is being used. uh, Suppose I'm using a memory only. What does this mean? So RDD get is saved in the JVM as a Java object. It is a default level. If you even though if you don't provide, so it will be picked up. But there's a problem, right? Suppose as we know, RDD consists of partitions. If suppose a couple of partitions are not getting fit in JVM, then what will happen? They will be computed at the runtime and they will not be saved in JVM. They will be computed at the runtime as needed. Second form is a memory and disk. It is similar to memory, only difference is that whichever partition is not getting fit in memory, they will be put on disk. The third form is a memory only serializer, right? In this, what is happened? The RD gets serialized as a Java object. For example, 1 byte array per partition. It is more space sufficient, but more CPU intensive option. Another is memory disk serializer. It is similar to memory only serializer. But the difference is that space partition gets saved onto disk if it doesn't fit in the memory. The last option is store as a RD partition gets stored in the disk as a disk only option. So the question arises, right? Which option should I select? Basically, we should always use memory only, okay? Because the computation will be faster and nothing saved on the disk, right? So, but what suppose the problem is that suppose certain partition are not getting fit in the memory, so it will not be safe, right? So, what is the mechanism they use? So, you use the least recently used caching policy. So, whichever partition is not getting used, right? So, they will be removed from the memory, and they will be computed in the runtime. Uh, so, question will be arising in your mind that what if a partition is not getting fit in the memory? Will Spark job will be failed? No, it will not be failed. Oh, what if I use disk only options, right? So, you can use that, but it's not going to solve your problem, right? Because saving on a disk, reading from the disk, right, the computation will be as good as saving on the disk. It will take that much time only when you save on disk, getting the data from the disk. It is better to recompute in the runtime in the memory. So this is regarding in this video where I talked about the caching and persistent. In next video, I will talk about the Spark architecture. Thanks for watching this video.